Hey, student, how are you? Welcome to our session on circles, graphing standard and non-standard form. Let's take a look at the standard equation of a circle. It is x squared plus y squared is equal to r squared, where r is the radius. The center of the circle is at the origin, 0, 0, and the radius is r. The radius is the distance from the center of the circle to any point on the circle. Notice in the formula, the radius r is squared. Let's take a look at an example of graphing a circle given in standard form. We'll identify the center and the radius. The center of this circle is 0, 0, and the radius, 9 is the radius squared. So we need to take the square root of 9 to get the radius, and we get 3. We'll graph the center of the circle at 0, 0, and then we'll use the radius. We're going to go 3 to the right from the center, up 3 from the center, to the left 3 from the center, and down 3 from the center to get the 4 key points of our circle. Taking a look at the translated circle equation, parentheses x minus h all squared plus y minus k all squared is equal to the radius squared. H is the horizontal shift, left or right. K is the vertical shift, up or down. So the center of our circle is h, k. A tip, you're going to use the opposite sign for h and k for the center, the opposite sign than the one that you see in the equation, because the minus sign is part of the formula. Let's take a look at an example. Graphing this translated circle. We have our translated circle equation, and I can rewrite y plus 3 as y minus negative 3 to match the translated equation of a circle so that we can clearly see what k is. Now we have h is 2. We have shifted the circle 2 to the right. H is the horizontal shift, and k is the vertical shift, negative 3, so we shifted down 3. So the center of our circle is 2, negative 3. There's our center, 2, negative 3 on the graph. And now we'll find the radius. 25 is the radius squared. So we need to take the square root of 25 to find the radius. Square root of 25 is 5. So starting at the center of your circle, you'll go to the right 5, up 5, to the left 5, and down 5 to get the 4 key points of your circle. Let's try another one, identifying the center and the radius of this circle. The center of the circle is h, k. H in this equation is 0, and k is positive 8.5, using the opposite sign than the one in the equation. And now our radius, 9/25 is the radius squared, so we need to take the square root of 9/25. We can take the square root of the top and the square root of the bottom separately, and we get 3/5 for the radius. Example number 4. Let's take a look at the expanded form equation of a circle. X squared plus y squared is plus 8x minus 6y plus 21 is equal to 0. First, let's group all the x terms, all the terms with x, and all the terms with y together, and then we'll subtract 21 and bring it to the other side of the equal sign. Now we'll set up our completing the square format, and we're going to complete the square. We'll take half of b, square it, and add it to both sides of the equal sign. So we'll start with 8. Half of 8 is 4. 4 squared is 16, so we'll add that on the left and on the right-hand side of our equal sign. Then we'll take a look at negative 6. Half of negative 6 is negative 3. Negative 3 squared is 9, and we'll add it to both sides of our equal sign. Now we can factor the perfect square trinomial, x squared plus 8x plus 16. And then we'll factor the perfect square trinomial, y squared minus 6y plus 9, and combine all the like terms on the right-hand side of our equal sign. And here is our standard form equation of a circle. We can identify the center, h comma k, using the opposite sign than the one that you see in the equation. So we get -4 comma +3. And then the radius is the square root of 4, 2. And then we can graph this circle now that we have our center, -4 comma 3. And then our radius will go 2 to the right, up 2, to the left 2, and down 2 to get the 4 key points of our circle. Let's do a couple more examples, writing the equation of a circle. So given the center and the radius r, let's write the equation of our circle. Setting up our circle equation, we'll identify h and k. H is 5, so we'll substitute 5 in for h. K is -1, and we'll substitute that. And r is 2. We'll substitute that into our equation. And now we can do a little simplifying. Y minus -1 can be y plus 1, and 2 squared is 4. Let's do another one. Writing the equation of a circle, given the center and the radius. We'll set up our circle equation and identify h and k. H is -3, so we'll substitute -3 in for h. 7 is k, and we'll substitute that in for k. And r is 6, and we'll substitute that. Then we can simplify x minus -3 will be x plus 3, and 6 squared is 36. Let's do another writing the equation of a circle, this time given a graph. First, we'll identify the center, and then we'll do the radius so we can write the equation. The center of this circle is right there at 3, -4. And then the radius is the distance from the center to any point on the circle. Looks like 1, 2. Radius of 2. So now we can substitute 3 in for h, -4 in for k, and 2 in for r, and then we'll simplify. Y minus -4, y plus 4, and 2 squared is 4. Last one. Writing the equation of a circle given the center and another point on the circle. Well, they gave us the center, h comma k, but we have to find the radius, the distance from the center to the point on the circle. So we're going to need to use the distance formula, or you could use the Pythagorean theorem. I'm going to use the distance formula, identifying x1, y1, and x2, y2. Substituting them into our formula, we get 2 minus -6 and -5 minus 7. We'll subtract and then square 8 and -12, and we can add them together, and our radius r is the square root of 208. Now we can substitute our information into our circle equation. H and k are the center, -6 and 7. So we'll substitute -6 in for h, 7 in for k, and then the radius, the square root of 208, is going to be squared. So we can simplify x minus -6 to x plus 6, and the square root of 208 squared is just 208. And that concludes our circles session. Thanks so much for joining, and I'll see you next time.